Hello and welcome to these video series. We're going to be looking at trigonometric equations, and we're going to look at how to solve some equations. In part one of these series, we're going to be looking at half-angle identities and how they can be used to solve certain trigonometric equations. The first problem we're going to be looking at in this video is tangent x over 2 plus sine x equals 0. And as you can see here, the tangent function has a half angle as its argument, x over 2. And we know that we'd like to make all the trig functions the same, either all sines or all tangents, etc. And we also want to get rid of any half angles, or make sure all the angles are the same. And one way to do that is to look at the half angle identity for tangent. Now we know that tangent has different half angle identities, and the one that will be useful for us is this one over here. So the first step would be to replace tangent x over 2 with its equivalent, sine x over 1 plus cosine x. So we get this equation over here. On this equation, one thing is simpler than the original formulation of the problem, and that is that we don't have any half angles. However, we have a fraction here, and we need to write down the same denominator. Having the same denominator on one side of the equation simplifies things greatly, so we're going to multiply the second term by 1 plus cosine x. So we can see here, instead of writing sine x, we're going to write sine x times this quantity to get a new form of the equation. And after simplifying, we're going to multiply the numerator out, so we get sine x plus sine x cosine x. And finally here we could see that this we have a common term, sine x plus sine x, so we're going to simplify and collect like terms to get the new form of the equation. So at this point, several things stand out. First, we see that the right hand side is equal to 0, and second, we see that we have a fraction, and we know that fractions equal 0 only when the numerator is 0. So we can go ahead and set the numerator to 0, but before we do that, we'd like to factor. So we see that sine x is a common factor here, so pulling that out, we can rewrite the equation and then set the numerator equal to 0. And that'll give us two separate equations. So sine x equals 0 and cosine x equals -2 from the second factor. Again, the denominator does not affect the quantity as far as making it equal to 0, so we could ignore that for now. The first equation, sine x equals 0, has two solutions, 0 and pi, in this interval that is. So on the second equation, cosine x equals -2, well, that's impossible. Cosine x is always between -1 and 1, so we can say that that quantity cannot be -2, and so that's not really going to give us any solutions. Another thing to note is that x equals pi would make this denominator undefined, would make this denominator 0, so that this fraction is undefined. Or we could go ahead and look at the original question. If we replace x equal pi in the original, then we see that tangent pi over 2 is undefined, so that solution doesn't make sense. And the only one we're left with that works is x equals 0 as our only solution.